With this video, I'm starting long series of solving trigonometric uh, identities, solving trigonometric equations, and simplifying trigonometric expressions. And whatever formula I will use, I will write down with red color so you will know which formula is applied to this or that trigonometric expression. Okay, so let's start. And then once I load up some decent amount of videos how to solve this or that problem, I have already prepared test yourself playlist where I'm going to post some problems that you are going to solve yourself, and then on the next video I will solve these very problems. Okay, so you can go and check yourself and see how to solve. All right, so let's see. I'm going to solve cosine x. Let me write down with this color. So we are going to solve in this video cosine degree 4x minus sine degree 4x, which means we are going to simplify, and then the other one is going to be secant degree 4 of x minus tangent degree 4 of x. Okay, so let's start. Cosine degree 4 of x minus sine degree 4 of x. Does it remind you a squared minus b squared? So I'm going to represent as a cosine square x squared minus sine squared x squared. That is going to be a squared minus b squared, the formula that we know from algebra. A plus b times a minus b. So in this case we are going to have, let me move it here. So we are going to have sine x or cosine x, cosine square x minus sine square x times cosine square x plus sine square x. Okay. Based on Pythagorean identity, we know that sine x plus cosine square x is equal 1. And I'm going to use this. This is too thick. So this one, which means this term is going to be equal 1. And hence, we are going to get cosine square x minus sine square x. And since it's going to be 1, so this will be gone because it's equal 1, this term. So cosine square x minus sine square x. Let's see what we can do here. Can I represent this sine square x I'm going to represent as a 1 minus cosine square x from this very formula. because if sine square x plus cosine square x equal 1, then from here sine square x will be equal 1 minus cosine square x, and that's exactly where I'm going to apply. So I'm getting cosine square x minus 1 minus cosine square x. Opening parenthesis, cosine square x minus 1 plus cosine square x, and I'm getting the answer 2 cosine square x minus 1. Okay? All right, so then this is the result after simplification. Well, minus 1. Okay. Next one, it's gonna be this case, right? Secant power 4 minus tangent to power 4. Minus tangent power 4. Again, breaking down, it's gonna be secant square x minus tangent square x times secant square x plus tangent square x. Okay, and based on Pythagorean identity rule, we have one plus tangent square plus 1 is equal secant square x. Okay, so this secant, I'm going to apply tangent square x plus 1. Let's see what we get. Equal tangent square x plus 1, and then minus this tangent square x times secant square x plus tangent square x. Okay, so what do we get? This is gone, this is gone. We have 1, so I can simply write down secant square x plus tangent square x, and this will be my answer. So after simplification, we can say that secant power 4x minus tangent power 4 is equal secant square plus tangent square. I would like to. There we go, much better. Okie dokie. See you next video.